Welcome everyone to this video on searching. We're going to look at two searching algorithms in Java. The first one is sequential search and the second one is binary search. So before we view these, please look at the description below. There is a link to a visualization of how the two searches work. I would strongly suggest you look at them before we look at the code so that the code will make a little bit more sense. So starting off, in order to search, what we're going to require is an array of numbers. They are going to be a bunch of integers, 1, 5, 8, 2, 3, 5, 8, 5, 4, 8. You'll even notice that some of them are repeated. This is because when searching, you will only find the first instance of something, not the last instance. The next two things we're going to make are a num, which is going to be 5 as an integer. This is the value that we are looking for. Now, and then we're going to create an integer named index, which is -1. This is the index at which we have found the number at. We are starting off at -1 because if we cannot find it within the array, we want to return -1 so that the user is aware that it was not found inside of our array. Okay, so first thing, sequential search. This is searching an array in order. This means from the first index until the last index. So sequential search is simple, but it is inefficient. It doesn't require it to be sorted. However, it does mean that if it cannot find the value, it will have to look at every single value inside of the array. It also means that when it does find the value, it will have to search at every single value before it. This is inefficient, and we'll find out why when we get to binary search. So to search this off, since we're going to go through every single index in the array, we're going to create a for loop which goes through that. It's going to start at 0, it's going to go until the number array length -1 since it is less than it, and it's going to increase by 1 every single time through the loop. Then what we're going to add is an if statement inside of that, which is going to check for when our number that we're searching for, num, is equal to the value at the index we are currently looking at, so number array I. If we find it, what we're going to do right now is we're just going to print it out, and if I run this, should print out the indexes of all the values that have 5. So index 1, index 5, and index 7. Now this is not very helpful to us. So what we're going to do is we're going to replace this. And what we're going to do instead is say that, okay, well, we found it, so we want index to be equal to I. And then we're going to end the array. So normally you might do this with something like a break. Another way of doing this is saying, I'm going to make I so that this loop's value will be false. So in other words, I'm going to make it equal to numArray.length so that it is now false and will not run any more iterations of our loop. And then what I'm going to do at the end is I'm just going to print out the index at which I found the number. So if I run this, I should get the value of 1, which is the first instance at which the 5 is found inside of my array. And that's sequential sort. That's all there is to it. It's a loop, one if statement, and then a output statement or a return statement depending on if you are using this as a method or as an output. You can also instead swap out this section right here with a return statement so that it will not run the loop any further. Now, on to binary sort. This is searching by halves. So in other words, what we're going to do is we're going to take the array and we're going to say, okay, well, if it's not here, we're going to search the half of the array that it is in. Well, in order to do that, this means that we have to sort it because we need the lowest values to be on the left and the highest values to be on the right. So we're going to sort it, and then we're going to create our values that we require. So we're going to require a middle. So what is the middle section of the array that we're looking at? What is the start of the array we're looking at? What is the end of the array we're looking at? And finally, of course, our index needs to be set to -1 again. Now you notice our start is at 0, our end is at the last index of the array, in other words the length -1, and our middle is at the length -1, but then divided by 2 to give us the middle. This means that if we have an odd or an even number, it will give the same result since it's an integer. 9 divided by 2, doing integer division, will give me the same result as 8 divided by 2, since 4.5 and 4 will both be written down as 4 when they're integers. Now, unlike the previous one, we will not be using a for loop for this. Instead, we're going to be using a while loop. And that while loop is that the start needs to be less than or equal to the end. This is because if the start passes the end portion of it, we know that we've already searched every index and we want our loop to stop. So now what we're going to do is we're going to create our segments of if statements that are going to allow us to do a binary search. So the first part is we're going to check, is the number we're looking at, in other words the number at the middle, is it less than the value we're looking for or greater than the value we're looking for? If it's less than the value we're looking for, this means that the value we're looking for is larger than it, so we're going to look at only the larger half of the array. In order to do that, we need to change the start to the middle plus 1, since we know middle is not the value, so we want to go 1 more than that. And then we need to change the middle to be the new middle. So we're going to take the start and the end, add them together, and divide by 2. So for instance, if this means that I have an array of a length of 10, if I have my end was 9 and my start was 0, now my start should be 5. So I should do 5 plus 9, which is 14, divided by 2 is 7. So 7 is the new middle because that's the middle between 5 and 9. Now we're going to do the exact same thing as an else if statement, since we only want to run this one if the other one wasn't true. And this is going to happen if our middle is greater than the value we're looking for. So in other words, this means that it's in the first half of what we're looking at. So what I'm going to do is the opposite of what I did before. Instead, I'm going to say the end is the middle minus 1. So I want to move before the middle, since the middle is not the value either. And I'm going to set a new middle the same way I did in the previous one. Finally, I'm going to create one more else if statement. Now, you'll notice that I've made a comment there that said this is a useless condition. This is because I could have simply wrote an else statement instead, since the only possibility left is that it is equal to the number. Everything else is taken care of in my 2 previous if statements. What I'm going to do here is, well, this means I've found the number, so I want to make index equal to middle, since that's the current index of the number. And then I want to break. Now, as I've talked about before, breaking is not something you generally want to do. If you are using break, this means that you are using improper logic inside of your while loops. So what I'm going to do instead here of breaking, I'm going to comment that out because it's not needed, since I can make it false in a different way. I'm going to instead say that the start is equal to the end plus 1. In other words, the start is greater than the end. Because if that happens, this means that I don't have to worry about my end anymore, since the condition, no matter where the end is, will now be false and start is greater than. Okay? And then just like we did with our sequential search, we're going to have a print statement for the index. So if I run this, you'll see the original one from our first one where it was at index 1. However, remember now that I have sorted this index, so it should be 1, then 2, then 3, then 4, and my first index of 5 will be the 5th element. In other words, index number 4. Okay? And that's all there is to it. So, binary search is quite simple. It just is going to remember that it takes our lists that must be sorted, or arrays, sorry, and it will look at 1/2 at a time, reducing it by half each time, making it so that the runtime of it will no longer be every element in it, but instead we'll be reducing it by halves each time, putting it at log n time.